Hi, I'm Dan. I'm an architect at Oracle, and today I'll be talking about multi-cloud. Multi-cloud is one of the most exciting things to come out of the cloud space at Oracle in the last couple of months. And so I had the privilege to go deeper into how exactly it works. In some of the demos you've seen, shown you that it does work. Let's talk about how we got here, why we got here, and how it works. For context, I've been here for about 8 years, right at the start of OCI. And I've spent the whole time trying to make this the most interesting place we can be. I work with the chief technical architect now on these projects that span and redefine what cloud really means. So let's get to it. Current clouds today, and OCI fits this, are a lot like walled gardens. They are ecosystems that are designed to be self-contained and reward you for being self-contained. They provide a bunch of benefits, but it's very hard to go outside of them. And a lot of times when people talk about multi-cloud today outside of the Oracle space, we really are talking about the idea that we want to be involved with more than one cloud. And so we build essentially roads between them. The approach can either be that I'm going to run the same thing in multiple places, or it may be that I'm going to run some things in one place and one things in another. But ultimately, this is really a many cloud strategy. And I gotta say, this multi-cloud strategy, while it solves the problem of having a single provider, really is quite stifling. And it's stifling for customers because you don't get to use the best parts, or you have to worry about being locked in as a result, or you add another abstraction. And even then, there's so many different idioms and so many different forms of access control that it's hard to feel really safe about what you've done. But it's also stifling for people like me who want to build interesting and great things, because we're really striving at this point to have to drive to the lowest common denominator, the features that do as well as everyone else does, because what you're looking for is consistency as opposed to excellence. And so what we're pushing for now is this idea to move from walled gardens into these connected gardens, into these connected systems that work together. And like I said, I'd like to go into the details of how we did so. In order to encourage people to adopt more of this. We want this to not be about exclusivity. That's sort of the nature of a walled garden. And so the perspective that I'm going to bring to this to start with is the identity space, because I spent the first 5 years at OCI really designing our authentication and authorization systems. And it's a very distinct discipline, but I hope that as I walk you through some of the ideas, you start to see why this is so fundamental to really breaking down these walled gardens. The last time I was allowed to speak at a conference, or the last time I had the opportunity to, was at Identiverse in 2019. It was a very hot summer in Washington, D.C. And my colleague, Dr. Lucina, and I gave a presentation at this conference of cloud identity called Identities for Everything. And what we were talking about was our new approach to how we think about principles. What we were talking about was called resource principles. And the idea is, I'm very opposed, the cloud is very opposed here to proof by possession type of things, or shared secrets, or sort of backdoors into authentication authorization. We really are quite proud of our signed requests, our very straightforward authentication, OAuth or whatever, but we like things to speak as themselves. And so what we proposed in this talk, and I'm not going to rehash the whole thing, was that we had come up with a series of definitions of principles and a series of methods for allowing everything in our cloud to have its own identity, and to be able to therefore talk to other parts of the cloud as itself. And so, what you end up being able to do is, for a separation of concerns, you can define what these behaviors are without having to have explicit, this is a member of this group, by having a thing called dynamic groups, which allows you to define the properties of a resource to say it's a member of this group. For example, in this one, we're creating a dynamic group that says every database as a service resource for which my custom policy or tagging thing is a tag namespace of policy for which I've used the backup value and marked it as active. And so we can take this broadly and say, this is a group for every database that's supposed to be able to back up. And then as a separation, we can then write some policy, and this is all working policy today, that says, allow this group to manage objects within the database backup area under a specific region and only create objects. So in this case, I can now say, I will have databases. I will mark the ones that I want to be able to back up, and now you will give it the authority to do so. But ultimately, what our approach to moving everything to everywhere was that all of our resources and all of your resources end up having very specific names. They can call each other and do the things you want to do in your infrastructure as themselves. So the audit log is clean, so the authorization story is straightforward, and there's not too many secrets or any secrets. And so two of the properties we talked about were both the idea of agency, that these resources can talk as themselves to other services, and projection, which is that we can transform from one kind of principle into another, doing a safe and secure protocol handoff, so that we can keep refining these principles into more and more intentionality of exactly what they're doing. So your database has its identity, even though it's actually running on a compute instance, for example. Or your function is a container running in our function orchestration system, but you can start authorizing your function or an instance of this particular function to do something. Now, what I didn't talk about at the conference was there's an additional property that we really liked about this, which is that these principles are therefore not constrained to OCI infrastructure. We're not using some special back channel. The protocols by which these exchanges happen are all on the surface. And so we have this environmental independence operator. And we couldn't talk about it because at the time we weren't doing it, and we don't like to talk about things we don't do. But very soon after, we upgraded the Exadata Cloud Customer experience to use these resource principles. So that Exadata Cloud Customer, where an Exadata lives within your data center, but wants to be managed or back itself up or interact with OCI, can do so as a first-class member of your tenancy, so that you can say, well, my Exadata can access this bucket, or my Exadata can make a service request or a support request even as itself, so that it doesn't have to be a human in the loop, and it doesn't have to be pretending to be a human or a user. It can say, I am this Exadata. This is who I am. But so obviously I wouldn't be talking about this if this was just to show off cool things that we've built within our own cloud and our own system. Instead, as we started thinking about expanding the world, the problem of the cloud gardens, we realized that while no one else has resource principles, there are similar versions in other clouds. So we have this elegant mechanism for services to be able to delegate which their resources are, authority from our IAM system. But there are variants in the other clouds as well that allow you to start to segregate out different resources as individual participants. And with that, well, we started to say, what if we could use this in our projection? And what we found was, yes, we can actually make these resources in other clouds act as OCI members, or do the closest approximation the other direction. And so restating those properties, when we start thinking about from a multi-cloud perspective, well, if we have these principles that allow a resource to call a different service, blur out that it's an OCI service and it's interesting. projected is this way to transmute them from one to another. And then the environmental independence is they don't have to be sitting in our facilities. And so one of the implementations that we can talk about, because we're live with this, is the Oracle Database Service for Azure, where the pitch is that they can provision, access, and operate OCI databases from within an Azure portal. This is where we're going to go a little deeper. So to get started with this, you do a sign-up process. And the sign-up process is that you log into Azure as in your Azure subscription. Then you select the Oracle Database Service from the Azure menu. You then provide consent to the database service, and then you're done. And what has happened at this point is we have bonded these tendencies together. Specifically, we see that there is an OCI admin facility in Azure. There's an OCI admin facility in OCI. And then within your customer accounts now on Azure and on Oracle, you have identity bonded together, tied into your Azure subscriptions. And to get a little more specific, we have, in this consent, set up 3 different authorities to talk. Right? In one case, we've said the customer has agreed to use this bonding, Azure, that's the authority to link Azure and OCI. Then we've said the OCI side has authorized it to use the ODSA service, has the authority to do so. And then finally, we start worrying about the minutiae of talking to Exadata itself, or whatever database service you choose to use. And so we can get these bonded together. You've seen this already. But I'd claim now that we are now beyond the many cloud variation of multi-cloud. I'm going to call this, for sake of differentiation, split stack multi-cloud. Because to me, what split stack multi-cloud implies is that the elements of your resources are, for whatever cloud you're working with, they present as if they were part of your cloud. You can interact with them, connect to them, attach to them, observe them, all as if they were part of your cloud. And so on our side, right, we need to ensure true interoperability. We're going to provide mappings so that the identifiers are native. We're going to bridge the networks so that you don't have to think about the network specifics. And we'll provide native interfaces so you don't think I'm using something else. And to walk through that, let's look at some of the interfaces here. On the left is the Azure version, and on the right is the OCI version. And on the left here, this is when you first said, I want to use ODSA after you've gone through the sign-up process. It says, what do you want to create today? It looks visually distinct from the same way you go to the database interface to say, I'd like to go talk about Exadata. Under the hood, what the customer is doing, what you are doing is logging into the portal, authenticating with Azure AD, and you have the authority to go use the ODSA portal. You're then making an Azure authenticated request as an Azure user into an OCI service. We're going to call it here for this the OCI multi-cloud hub, which is then going to use its authority to call Azure AD and verify, that this user is authenticated and authorized to make the request they're doing, in this case, creating an Exadata, and then start talking to the Azure Resource Manager to set that up for your tenancy. And once it's validated that this is a request that we should go ahead with, it works with the IAM system of OCI to create a credential and to transform the entire request so that the request in number 5 and the request in number 12 on the diagrams are the same intention, but the principle, the authentication, and the details of it have been transmuted into something that OCI understands natively. We'll get to the details on that in just a second. But so if I go to create a Exadata using ODSA on the left, not only does the interface look the same, but the resources that I'm talking about, the network I want to attach to, the name and descriptor I want to give it, are specific to how an Azure user should think about something like a database. Whereas on the right, we still have the OCI version of how you should think about this stuff. So in the next vision, it's not just that you have to do browser tricks. Because we're using Azure ARM in this case, you can make a direct request as the Azure user, and it will forward it along to the OCI multi-cloud hub, which will do the same translation and do the same thing. So the path to create an Exadata by Terraform, by command line, or by the web interface, it's all the same once we're past this hub, or once we're past this ingestion point. So after you've created this Exadata, you now see that in the Azure view, it looks like an Azure resource. Not only is it the UI, but the identifier you gave it, everything, it's all mapped there. Whereas on the OCI side, it remains with an OSID connected to a VNIC onto a virtual private network, and so on. And what I was hinting at was you get the full versions of these things because the services themselves are actually kept from the details of it. As far as they're concerned, you've created an Exadata. Now, whether you choose to get the monitoring to go to just OCI or to Azure and OCI, whether you are using IAM policy or Azure policy, these have all been abstracted from the services themselves so that they don't have to think about what a multi-cloud world looks like. And so your metrics can go wherever you want. It looks native. And again, that's the pitch done. But when we look at it from the resource principal perspective, we start to see that because we can abstract that away, because they can use these native integrations, we can use the same backends, get the same features and capabilities. There's no lag. And that these Exadatas can live simultaneously in both clouds because they live in one place and project into other places. Now, that's the identity side. But there is, of course, the connectivity thing, which is that we want the network interfaces to also look the same. And so this is where, again, you have choices. You can make it just it's a thing on the internet, but you can also have that privacy that we work so hard to provide in OCI. So, for example, if you have a thing that just connects to your network, just attaches to your VCN in OCI, we're going to do the same thing on the other side. So you're going to just provide your virtual private network, and no internet gateways are going to be needed. All of the details are handled over our private interconnect and tied away. We are doing a multiplexed multi-cloud tunnel end to end so that traffic is never crossing each other. It's using a shared link, but the advantage of that shared link at an abstraction layer is that we take care of it. You don't have to worry about that network, whether it's reliable, whether there's a thing that has to be done. That's all set up for you. You never had to think about that. Instead, you just had to say, I want my database and I want it on my private network. Or instead, right, in OCI, if you're using something like Autonomous Database, the shared version, that presents itself as a service and not as a particular resource. But the interface on OCI is that we share it as a private endpoint. It appears as a small little wormhole for just your service, for just your instance of the database, goes over this network connection, which is really great and convenient. Well, we figured out how to do the same thing on Azure so that, again, your Autonomous Database shows up as a private IP and not just as a bridge subnet of services that you didn't want. You can, again, keep your network constrained there. But that's great. What about latency? It sounds like we added a bunch of complicating things. Your database doesn't live there. Well, we think about this, of course. And for a lot of the databases, the cost of latency round trip between these interconnects, for example, is a manageable 1 to 2 milliseconds. It's not awesome. We'd always like to be faster. But that is a thing that feels reasonable in that space. But we don't always say it has to go over the bridge. It's always going to come through OCI. This is just a way for us to do more. As in the example of Exadata Cloud Customer, the latency there is the most important part, and the privacy. And both of those mean that the computer itself, the hardware itself, lives in your data center. And it uses the multi-cloud capabilities we're developing to do things that are not as critical path, but that require the safety and security. So for example, also the AWS or the MySQL HeatWave service is very latency sensitive. If you look at the numbers on it, as many of these talks will talk about, incredibly fast, incredibly efficient. And 1 to 2 milliseconds would hurt the performance drastically. For if you're trying to pull out terabytes of data from your S3 bucket, there's the transit fees too, which no one wants to deal with. And so instead, for a service like the HeatWave on AWS, we brought the computers to AWS, but we stuck the resource principals on it so that it can still phone home. It can still provide observability and metering and identity federation to your OCI experience so that it can integrate into that whole ecosystem of OCI and not just be a standalone thing. And again, there's a lot more that's going to come out with that. But the idea is the computation had to move close to the data, but the results of the computation, maybe you want that over somewhere else. And so ultimately, this concept of split stack multi-cloud, where you're building your applications with resources around the clouds, we're just getting started. At CloudWorld, we're rolling out more things. You can look at this and anticipate that there are more things coming. But I hope the takeaways you have are, we believe resources should be first-class citizens in a cloud, because ultimately we want everyone to choose the best services and the best resources of any cloud and get to use them together, not have to choose which one is best for your thing. Get the best of everything. That final takeaway, the many clouds version of multi-cloud is stifling, where there are a whole bunch of neat innovations coming out with split stack multi-cloud. Thank you for your time and attention.